That was a close one. I nearly went to that desk where I was teaching maths this morning. So if I lapse into mathematics, please stop me. So I'm here for quite different purposes. My name's John Appleby, and I'm chair of the Riddell Lectures committee. I'll tell you a little bit about those. But welcome. I'm glad so many people could come. And I look forward to a really interesting lecture tonight and tomorrow from our speaker, who'll be introduced by Patrick Rosencrantz in a few moments. These lectures, I think I'm supposed to start with a bit of housekeeping. So we don't expect any fire alarms, but there are fire exits at both sides, and we have stewards who will direct you out of the building. The lecture will last about 3/4 of an hour, and there'll be time for questions afterwards. I think that's the main thing I need to say. The Riddell Lectures have been running for about 100 years. Maybe we'll have a centenary one in a couple of years' time, I'm not sure. And they were endowed by Sir John Buchanan Riddell in memory of his father, and have been running ever since, typically every 2 or 3 years, and on a subject relating religion to everyday life. So we've had all sorts of speakers, and looking back through the list, I picked out some really striking names, such as in 1943-44, C.S. Lewis gave the Riddell Lectures. Rather more recently, we had in 1990-1991, both John Polkinghorne and then Jonathan Sachs. A bit later, Rowan Williams, and then our last two speakers were Sir James Macmillan and Lucy Winkett. And it was supposed to be every couple of years, but between 2020 and today, there was something intervened, so we haven't managed to have a lecture since 2020. We're very pleased to restart the series. So that's about the Riddell Lectures, and each time the committee meets and tries to choose a speaker who'll be interested in relating religion to science, archaeology, other subjects. And as you'll hear, our speaker tonight will be doing just that. And I'm going to invite Patrick Rosencrantz to introduce him. Thank you, Patrick.
Thanks, John. Is the mic on? Can everybody hear me okay? Yeah, brilliant. Super. Well, good evening, ladies and gentlemen. Lovely to see you all. My name is Patrick Rosencrantz. As John said, I'm a senior lecturer in psychology, and I teach a course, a final year undergraduate module in the psychology of religion. And Professor Barrett's work features quite heavily in this module, which my students, who I hope, I see some of them here, will be able to confirm. So you can imagine that it's an absolute delight to welcome you to Newcastle and to this year's Riddell Lectures. And it's a real pleasure to introduce you today. Justin is regarded as a founder of the academic discipline known as the cognitive science of religion, which looks at the natural foundations of religious beliefs and practices. These natural foundations are often best observed in those minds that are still developing and growing their capacity for culture, and in other words, young children. And I think it's fair to say that Professor Barrett, Justin, for me, started off his career as a developmental psychologist. He completed his PhD in the cognitive developmental lab led by Elizabeth Spelke and Frank Keil at Cornell University. And this focus on developmental psychology can still be seen in much of his later work. For instance, in a book entitled Born Believers, The Science of Children's Religious Beliefs. Since Cornell, Professor Barrett has held numerous academic positions. I'll just list a few. He worked at Calvin University, the University of Michigan, and at Oxford, where he helped start the Institute of Cognitive and Evolutionary Anthropology and the Center for Anthropology and Mind. Further, he worked at Fuller Theological Seminary School of Psychology. He's an author and editor of over 100 scholarly publications. That includes books. I've mentioned one. There's a long list. Edited books, as well as numerous journal articles. And these still shape the field of cognitive science of religion. I tend to make my students read some of these, but not all. To characterize his body of work, a summary could be that it's concerning scientific approaches to the study of religion, or the study of religious thought, as well as going beyond that, the philosophical and theological implications of that. He's interested in a science-informed perspective on human nature and purpose. Today, he works as the honorary professor of theology and the sciences at St. Andrews, but goes beyond the purely academic sphere, is co-founder and president of Blueprint 1543, which is a non-profit organization concerned with integrating Christian theology with the sciences to answer life's biggest questions. And the question addressed in today's talk is what makes cultural innovations so attractive? Lessons from the cognitive science of religion. So without much further ado, I will hand over to Professor Justin Barrett, and welcome to Newcastle.
Thank you. Thank you so much. A few years ago, I was on a plane, and across the aisle, maybe one row up, there was a young couple with probably a 9-month-old baby. And because babies aren't made for air travel, it was making those noises that say, "I'm not made for air travel." Squawking and squealing. And so I was doing my best just trying to keep my head down and read my book. It probably wasn't this one, but this is a really good read. But the squealing and squirming didn't stop. And you could sort of feel the people around starting to twitch uncomfortably, and why don't those parents sort of get a hold of their child and do something about this? This is going to be a miserable flight. So I rallied. I started doing what I could do, which was and she stopped. I had to keep it up for about 15 minutes. The lady sitting next to me leaned over and said, "You're our hero." But I did what adults have been doing for thousands of years with small children. Why didn't the parents figure it out? Well, they had tried a different tactic. They'd put one of these in her hand, and it was failing. Fast forward to just a few months ago. I was in a cafe with my wife, and we got our coffee, and we're going to go sit at a table, and we saw a mother with a toddler who didn't really want to go over to this table. And in fact, Mom said, "We're going to go sit over there." It went and almost left the cafe entirely. And so we see her scurry away after, and then come back with the child following dutifully behind her because she was doing this. She was luring the child with a phone, like trolling for a pike or something. It was remarkable. Clearly, she didn't get the message. Because in that intervening time of about 3 years, lots of psychological research has emerged showing the negative consequences of putting these things in the hands of small children. It's really not a good thing to do. And yet, you've probably seen this, as I have. It's all over the place. Parents still put smartphones, tablets, and other things in the hands of toddlers. It's almost like these technologies have spread too quickly, too broadly, and too deeply, and they're really difficult to uproot now. That's the problem I want to address in these 2 lectures, is not identifying just which technologies exactly are the problem, because that would make this lecture dated very quickly, because there are always these new technologies. Instead, what I want to try to do is give you some resources for anticipating which are those new technologies that are likely to spread broadly and deeply, such that they become so deeply rooted in our day-to-day kind of activity that if they turn out to be bad, if they turn out to have deleterious consequences, it will be hard to undo. It's hard to remove them. It'll be hard to give it up because it's so much a part of our lives. Okay? I'm using technology in a very broad sense here. I mean, my example is, of course, this sort of high-tech sort of science-derived technology, but let's use the term broadly to mean all kinds of human innovations that have been designed to solve particular types of problems. So it could be a hammer, it could be a smartphone, but it could be a particular social institution or arrangement, or a ritual, or some other kind of technique, right? Similar word to a technology. So that's what I have in mind. And tonight what I'd like to do is share with you some insights, largely from the cognitive science of culture, especially the cognitive science of religion, that might give us some heuristics, some tools for anticipating what are those new technologies that are going to spread broadly and deeply, or likely to, so that we can kind of anticipate them. That'll be tonight. And tomorrow I will then try to use those sort of lessons learned on some specific examples of some technologies that might be concerning you, including smartphones, to see, can we discover some other lessons learned? And then maybe at the end bring in some suggestions about how technology should serve sort of noble human purpose and human flourishing. So that's where we're headed. So tonight, I want to turn to the discipline that I know very well, which is the cognitive science of religion. As Patrick mentioned, I was sort of there in the beginning, and it's matured a lot and brought in new researchers and new perspectives, but it's all built on a theoretic core, at least most of it is, that's actually called the epidemiology of representations. What a terrible term, epidemiology of representations. Epidemiology, of course, is the study of disease and how they spread. And the epidemiology of representations is a notion that has been developed by French cognitive anthropologist and cognitive scientist Dan Sperber. He notes that for an idea, for a practice, for a tool to become cultural, it has to spread. It has to sort of spread beyond individuals into a population and stabilize. It has to successfully reproduce. Otherwise, it's not cultural. It's just some weird thing that guy over in the corner is doing by himself, right? It only becomes a cultural thing if it manages to spread within populations and then stick around enough that we go, hey, that's cultural. All right? So that's where the intuition is coming from. And he says, look, representations, what he's going to call representations, are a little bit like viruses. At least they can be studied a little bit like viruses, in that they need to have a good host in human minds in order for them to replicate and spread. So to be able to predict which are the kinds of things that are going to successfully spread, we can't just study that cultural form or candidate for a cultural form. We have to study how the candidate fits with the host, and in this case, the human mind. Like, say, viruses, replication is not guaranteed. If the host has an immune system that tries to kill it, it may not replicate. If there are mutations, it may not replicate in similar form. It may change dramatically, as we've seen with the various strains of COVID, for instance. Okay, so we need to understand that interaction between the virus, okay, and the analog here is the cultural form, and what's going on in the host, human heads. All right? And if we can understand better that interaction, we can better anticipate, well, what are the kinds of things that are likely to spread and become cultural? Now, Sperber and his colleagues Sperber has done a lot of the theoretic work in a broad sense about culture, but this has been worked out by some of his colleagues, such as Scott Atran, in the domain of thinking of folk biology. How do certain kinds of ideas about the natural world, plants and animals, how do they spread and become cultural? Larry Hirschfeld in social categories, including race categories. And Pascal Boyer has been one of the leaders in looking at religious concepts. So how does this work? That was very broad and theoretical. Let me give you some concrete examples. So for instance, we might ask the question, why is it that all over the world, across cultures, throughout history, it seems, we see various kinds of cleansing rituals. Okay? Ritual hand washings. If you enter, of course, a Catholic church, there's crossing with holy water. That's a cleansing ritual. Baptisms are a type of cleansing ritual. They're all over religious traditions, all over the world. Why is that? That's the kind of stuff that these sort of cognitive scientists of religion might be interested in. And Pascal Boyer and Pierre Lénard have collaborated in exploring just that kind of question. Why ritualized behaviors of that sort? And what they've observed is that we have independent evidence, developmental evidence looking at young children, clinical evidence looking at certain kinds of psychological disorders and other kinds of just odd behaviors, that humans have, as well as cross-cultural evidence, that humans have some kind of I think of it as an evolved mechanism for dealing with unseen hazards in the environment. So Boyer and Lénard call this a hazard precaution system. Hazard precaution system. Those unseen hazards, this is different than a flight and fight or fight kind of instinct. That's for stuff you can see, or at least you're pretty sure you could see if, maybe you hear it first, but when a bear comes after you, that's a different kind of environmental hazard. You can see that. Okay, I'm out. Or I'll push you down first and then I'll run, I guess, is what you have to do with bears. Because you can't outrun a bear. You just have to outrun the other. Okay, that's not funny. It's dark. But what about unseen hazards? Like viruses, bacteria, other kinds of pathogens like that. Well, then what we need to do is mark off clean spaces. And we need to patrol those boundaries. We need to wash our hands. We've been taught maybe we need to wear masks. It's actually very easy to trigger those kinds of then ritualized behaviors in the face of these unseen pathogens. And the system, they argue, is a naturally evolved kind of system in humans. It serves us very well, but every once in a while it can sort of run wild. And in its sort of pathological form, it turns into obsessive compulsive disorder, for instance. In religious contexts, it might turn into scrupulosity of certain types, or people sort of over-ritualize things. We see some interesting points in development where children seem to be especially concerned with patrolling boundaries and keeping things clean. Expectant mothers will start exhibiting certain kinds of OCD-like behaviors sometimes at certain points where it turns out their baby and they are very vulnerable to infection. Okay, so I'm pointing to there seems to be this natural system that has to do with processing information and motivating behaviors that arguably is part of our evolved endowment, that then makes the idea of needing to do certain kinds of ritualized behaviors very intuitive, very sensible. What happens then if you create a cultural system that piggybacks on those intuitions, that manages to trigger those intuitions by suggesting that there are other kinds of unseen hazards out there of a spiritual nature, for instance? Well, we've got a system that knows what to do with that. We need ritualized behaviors of this cleansing ritual variety, or other kinds of boundary patrolling varieties, like sacralizing certain kinds of spaces and making sure they are sacred and clean of contamination. That's the sort of account that Boyer and Lénard give. Let me give you another example of how cognitive science of religion sort of works epidemiologically. So that's right, I've given you evidence of what's going on in the host head that makes it receptive to particular kinds of cultural inputs. What about the belief in gods that are somehow responsible for the creation as a whole, or at least particular aspects of the natural world? Why are those so cross-culturally recurrent? Why are they so easy to teach children? Well, one account might go like this. Again, independent evidence by psychologists such as Deborah Kellerman shows that from early childhood, we've got a natural tendency to see design and purpose in the world around us. Yes, artifacts are here for a reason. They've been designed with a purpose in mind, but not just artifacts. If you conduct the right kinds of interviews with small children, you will find that they think that rivers have a reason, a purpose. They will tell you things like, rivers are here so we have some place to go fishing, or some place to sail our boats. They think mountains have purposes. They think tigers have purposes. This is sometimes, Kellerman initially called this promiscuous teleology. She since just talks about teleofunctional reasoning in children and notes that this kind of teleofunctional reasoning, thinking about purpose and design, is actually a natural thing that we seem to do, unless we're discouraged from doing it in certain domains. Okay, did you follow that? The conceptual path of least resistance is to think that the natural world has design and purpose behind it. It's only in certain educational environments where kids get taught, no, only artifacts have design and purpose, not stuff of the natural world. She's done cross-cultural studies that demonstrate just this kind of an effect. Okay? Well, if the natural world has design and purpose, well, that doesn't necessarily mean someone is behind it, but sure enough, kids have that intuition too, that the most sort of ready explanation for that purpose is someone did it, someone brought it about, someone accounts for that design, that goal, those ends. Well then, we have a natural receptivity to the idea of a creator God, or maybe nature spirits who account for why things operate the way they do in the world around us, why they exist. So there's this cognitive receptivity based on just the way that our ordinary human minds developing in ordinary human environments emerge, how they mature. That makes this cultural input, creator God, find this a really comfy home. It's easy to think about, it seems intuitively plausible, it's easy to replicate. It becomes cultural very easily. Okay? Third example. Why is it that all over the world, people have this intuition that there is something about me that's separable from my physical body? And this gets cashed out in different forms. It might be a mind-body dualism. It might be the idea that I have a spirit or soul. But however it gets cashed out in the local particulars of a culture, arguably it has a common cognitive root. Now, this is a much more contentious space than those first two. There's lots of debate about exactly how this happens, exactly how natural in a certain respect that such beliefs are. But a typical story goes this way. The cognitive systems that we have, again from early childhood, just by virtue of being human beings, are very attentive to sorting the world into the living things, the non-living things, and among the living things, those that have minds or have intentional agency. And we see evidence of this very early in childhood. Okay, clever little experiments will show even infants who can't speak dissociating between different kinds of displays, such that you can tell they see the difference between agentive type of movement and non-agentive movement. They treat living things different than non-living things. These are very early developing distinctions. It's sometimes called a folk ontology that then structures the way they sort of organize the stuff of the world around them. And then they attribute certain kinds of properties to those different things. Humans are an interesting case because we're living things, we're physical bodies, and we're intentional agents all at the same time. But it looks like the cognitive systems that are a natural product of just how our brains develop have different input conditions for those different sets of attributes and traits. And so they, of course, they generate different outputs, but they also have different input conditions. And it's easy to see why that would be. Because intentional agency, for instance, reasoning about minds, what's going on in your head, the beliefs you have, the emotional states you have, your consciousness, me attributing that to you is something that is very scarce in other animals. There's only slight suggestions that maybe chimpanzees do this to a certain degree. Maybe elephants do to a certain degree. Maybe dolphins. That might be the entire list of non-humans. But humans do it at a completely different level. We not only attribute thoughts to each other, you know, I assume all of you looking at me right now are thinking something. We're also jointly attending. In this case, we're jointly attending to what I'm talking about. I assume that you're kind of with me. Well, then I'm attributing to you thoughts about what I'm saying. And you're thinking about what I'm thinking about. We don't have much evidence that chimpanzees can think about what another chimpanzee is thinking about their thoughts, called meta-representation. Okay. Why am I belaboring that point? I'm making the point that the evolutionary history of that kind of what's sometimes called mind reading or theory of mind is fairly late developing in a primate line and therefore very independent of thinking about physical bodies. It's a different system that, interestingly, doesn't seem to need physical bodies around for it to operate. We can think about the thoughts and the actions and the desires of people we can't see, that aren't in the room right now. Infants seem, their agency detection system that readily then moves into intentional agents actually can operate on two-dimensional little disks moving on a computer screen. I suspect many of you in here have attributed thoughts, beliefs, emotional states, and maybe ill intentions to computers, cars, and other kinds of things that aren't living, at least not in the usual sense, and are certainly not people. It's okay. Don't be embarrassed. We all do it. The reason we do it is there are enough of the right signals of agency that then trigger our sort of flip the right input conditions to tell us, oh no, there's an agent here. And with humans, it's so important for us to assume agents also have intentions and conscious mental states that we go straight there and maybe have to dial it back later. Okay, yeah, I know the computer isn't deliberately trying to frustrate me. Sure seems like it, and I'm gonna kick it anyway, just to be sure. Okay, so our system for thinking about agents, about minds, is actually dissociable from bodies. Different inputs, different evolutionary history. Well, if that's right, then there's actually nothing terribly difficult about suggesting a disembodied agent. Or that mind thing isn't just my body, it's something else. This has led many psychologists, Paul Bloom, Jesse Bering, among others, to suggest that some kind of intuitive dualism is actually the default mode for humans. And we see evidence of this actually in ancient writings around the world, too. So the idea that we are nothing but physical beings, and the mind is some epiphenomenon or something like that, is a very counterintuitive idea. If intuitive dualism of some sort is the conceptual path of least resistance, is sort of our natural default, then if I suggest to such a mind there are disembodied agents, it says, I'm prepared to receive that idea. That seems really sensible to me. Thank you. Well, what if that body dies? Could its agency continue after death? Absolutely. That makes total sense to me because it wasn't dependent on the body anyway. That agency wasn't dependent on a body anyway. All right, so I'm just trying to paint a big sloppy brushstrokes picture of the kind of rationale or strategy that cognitive scientists of religion use to account for why it is that certain kinds of cultural expression that we might call religious are so recurrent over and over again. They're easy to teach to young children. They spread in populations. They sort of are independently invented over and over again in lots of different cultural contexts because they've got a natural home in our cognition, just by virtue of being human beings living in ordinary human worlds. Okay? There are a couple of other little sort of tweaks on this story that are kind of interesting and that will serve us tomorrow. One of those little tweaks is the idea that things don't have to be perfectly intuitive to also find a pretty fertile home in our minds. They just need to be mostly intuitive. They need to be easy to think. Right? Some things are easier to think than others. If you didn't notice, I was assuming that you would believe me on that. Is everybody okay with that? That some things are just easier to think than others? Because that's actually not an uncontroversial idea. Lots of us have been taught, either actively or sort of passively, that human minds are just a blank slate. You've heard that, tabula rasa. I think it was William James who said, we come into the world with, and the world is just a blooming, buzzing confusion. Contemporary cognitive developmental psychology says, no, that's just not right. We come into the world with strong predispositions one way or another, or at least dispositions to learn or acquire knowledge in particular ways. One of my favorite examples is a really straightforward one. That's fear of snakes. Fear of spiders works too. It is very easy for a baby to become afraid of snakes. In fact, some experiments suggest that all it takes is a single episode of mom or dad reacting to a snake with fear, and now they're afraid of snakes too. But if mom reacted in fear to a flower, they're not going to become afraid of flowers. They're going to think something's wrong with mom. All right? Snakes, yep, got it. I was just in St. Andrews doing some different lectures, and one of the professors there at the university shared with me who I had met living in the United States. He's returned to the UK. And he was saying, one of the great things about being back in the UK is there aren't all of these things around trying to kill you. And he meant animals. There aren't all these animals trying to kill you like in North America, which I guess is kind of true. There are lots of things that can kill you in North America. They've been eradicated here, so it's much safer. But he didn't have in mind our grizzly bears or timber wolves or things like that. He had in mind spiders and snakes. In fact, the example he gave is, in my house in the United States, you could open a cupboard and there'd be a dozen of these venomous spiders that could kill you. He went on to tell me a story about he lives on a farm and how the farmer's bull got out. And he immediately ran outside to try to help corral this bull that destroyed his terrace. That's an animal that can kill you. It completely escaped his attention. Whereas these little spiders, yes, they're venomous, but he's a big man. It's not going to kill you. But in his mind, spiders are dangerous. Charging bulls, meh, negotiable. Why? Because we've got a natural predisposition, a preparedness to become afraid of spiders and snakes. We don't have that for cattle. Okay? We're not a tabula rasa. We have all of these interesting maturations that are sort of almost inevitable given ordinary human environments and ordinary human biological endowment. Okay? That's the backdrop to this kind of approach to an epidemiology of culture. But things don't have to be, like I said, things don't have to be perfectly natural. They just need to be pretty close to those anchor points to make them easy to think and motivating in some way. So, it may be the case that an invisible person, for instance, well, let's leave people out of it. Let's talk about an invisible dog. Okay, not intuitive. But it's really not that hard to think about. Give it a second. Imagine an invisible dog. Did that hurt? Probably didn't hurt very much. Compared to an invisible dog that experiences time backwards, only exists on Wednesdays, sustains itself on crude oil, and gives birth to kittens. Okay, that's really hard, right? In the jargon of our area, that's the difference between something that's sort of minimally counterintuitive versus massively counterintuitive. But that invisible dog's a lot more interesting than just a brown dog with floppy ears. It's going to be more memorable. It may, because of that property of being invisible, generate a little bit more speculation, a little bit more thought, be worth talking about. I think last night I was attacked by an invisible dog. It bit me, I turned around, it was not there at all, and you're like, okay, you had too much to drink, probably. Until you run into my friend who says, I had the same experience. Where were you? Same place. Were we sober? Yes, we were. Okay, invisible dog suddenly becomes plausible for a moment because it's not that hard to think. And little local folk tales actually seem to spring up around these things in various places. Part of the recipe for success seems to be really easy to think about, generate intuitions, predictions, and explanations that are relevant to the life we live, especially meaningful things about the life that we live, like avoid that area, bad stuff happens. Invisible dog or not, that's a bad place to be. And not be too crazy, not too much weird stuff. And then you've got a really good chance of replication, and we've done various kinds of memory and transmission experiments that actually demonstrate just that, where we've given adult participants in various parts of the world these kinds of strange concepts and see, well, what do they remember from these? What can they retell? And it turns out that if they're just a little bit counterintuitive, they actually do really great under a lot of conditions. Okay, so that's one little tweak on my naturalness story. Let me give you one more tweak. It's called superstimuli. Superstimuli. Dan Sperber and Larry Hirschfeld have developed this idea nicely. You've experienced superstimuli. The idea here is that our conceptual systems are busy sort of finding things in the world and thinking about certain things, or you could even extend this to our general physiology. It's attracted to certain types of stimuli, and it needs to detect those in the world around us. The sort of easy textbook example is sweets. So many of our desserts and candies and things are a super stimuli in the sense that they have much more sugar than you would ever encounter in the normal sort of world. They're extra, extra sweet. And so they sort of swamp our taste system with that sweet thing. And why does that matter? It matters because, at least the sort of textbook kind of account of this sort of thing is in ancestral conditions, you need motivation to find certain kinds of foods that are good for you. Well, where do we normally find sweet stuff? In the foods that are high in lots of vitamins that we need. Maybe in berries, for instance, which are very healthy and nutritious, but also perish quickly. They have a very short season. You can't just hoard them. They go bad. And there are other animals that want to eat them too, especially birds and, in North America, bears. Of course, bears. They're fighting with you for the berries. And so you need a lot of motivation to get in there and get those berries, because they have thorns and things too a lot of times, right? Blackberries and raspberries have thorns and stuff. So we need a motivation to get that. So we're attracted to sweet stuff. But because of refined sugar, we can get plenty of sweet stuff. And so our taste system then gets sort of overwhelmed by these, and we're like, oh yes, please, super sweet. And then we have diabetes. So it's not good for us in that case, but that's a super stimuli. More interesting one is this. From birth, babies pay extra attention to human faces. Right from the womb. Some studies have suggested that within hours after birth, they selectively pick out faces in the environment and maybe even imitate some facial expressions within a day of birth. especially this one, the sticking out tongue. It seems to be a really strong one. That's right. So like a day-old baby not only finds the faces, but then somehow maps its expression onto its musculature to imitate facial expressions. And it doesn't even know it has a face. I mean, that baby, it doesn't. How does it know it's got a face? But it doesn't. Why? We're especially social species. Faces give us a lot of information. What other people are paying attention to? Are they looking at me? Lots of people are looking at me. It's a little uncomfortable. Or are we both looking at the same thing? We can read each other's faces. And this is part of the scaffolding for social learning. So babies need to find the faces. Fun little side note, girl babies pay more attention to faces than boy babies, interestingly. But that's a very natural type of thing, is to look for faces. In particular, what they seem to be attending to is eyes and mouths. Okay, things that look like two eyes and a mouth. So you can kind of trick the face detection system by having two dots and a line going this way, not this way. If the line goes this way between the eyes, it doesn't work. If the line's up here, like an eyebrow, that doesn't work. Two eyes and a mouth. They go, okay, face. Their face detection system says, I found a face. Well, that's a signal detection problem, right? They have to find that target amongst all of the background stimuli. So even better is superstimuli that exaggerates the distinction between the figure and the ground. So bigger eyes, bigger mouth is even more attractive to our perceptual system within bounds. If it gets too exaggerated, it feels funny. But it draws more attention. And so it's no surprise that in many cultural systems, we see things like masks with huge eyes and huge mouths. Because that immediately says to an audience, say it's a theatrical audience, or in a religious ritual, that's a person. It's a faced thing. Even if the proportions are completely out of whack, it's superstimuli. Makeup does this sometimes, right? Lots of eye makeup is designed to make the eyes bigger. It draws more attention automatically because we're looking for faces. So that's called superstimuli. A third category of this that seems to draw lots of cultural forms is hypersexual kind of stimuli, where maleness and female differences are exaggerated in stimuli. You see this a lot in, say, superhero comics. The men are way too V-shaped, the women are way too curvy, that kind of thing. It's like, what's that about? Well, it's a similar kind of thing. It's exaggerating the signal that we're looking for that means femaleness or maleness from a natural sort of perspective. All right? Superstimuli. So that's another way to sort of get of a candidate for a cultural form to get its hooks into our psychology, such that it's really easy to represent, easy to talk about, easy to transmit. Makes it attractive to us. To summarize this kind of approach very quickly, Robert Macaulay, a cognitive scientist of religion and philosopher of science, has offered the idea of a continuum of, you might think of it as of a continuum of naturalness. On one end, you've got what you might call maturationally natural kinds of cultural expression. This is the stuff that is characterized by fluency, automaticity, and ease. In that sense, it's natural. Oh, walking comes natural. It's natural to me. Look at me naturally walking. Okay, that was more of a strut than a walk, but you get the idea. That's easy. I don't have to pay a lot of attention to it. I don't have a lot of sort of executive or reflective conscious resources dedicated to it. I can just do it. Fluency, automaticity, and ease. That's been with us for a long time as a species. That's common across cultures and within populations. That typically emerges early in development. such that if it doesn't show up by maybe age 5 or 6, we might be taking our kid to the physician to say something's wrong. Those types of behaviors, those types of expressions tend to be anchored deeply in our maturationally natural cognitive or psychological systems. So, speaking your native language is a good example of that. We don't have to teach it. We don't need special cultural conditions. We don't need special artifacts. That's maturationally natural. Walking, talking. On the other end of the continuum are those kinds of behaviors or forms of cultural expression that, if they ever reach fluency, automaticity, and ease, it's because of lots of practice, very special cultural conditions. They probably haven't been with us for very long in human history. They probably developed a little bit later in life. They're probably very irregular across cultural conditions. Think of chess mastery. Right? Some chess masters have fluency, automaticity, and ease, but they had to have a chessboard at some point. They had to be taught the game at some point. They needed those special cultural conditions, and they needed to practice a lot. Or you might think of a virtuoso on a piano or a violin. Okay, that's over on this end of this continuum. What else might we place on the continuum? Well, Macaulay really develops this in his book called Why Religion is Natural and Science is Not, an Oxford University Press title from, I think, 2011. And he wants to make the case that not quite as natural as speaking my first language, but somewhere down on this end are most religious forms of expression. For just those reasons I talked about to begin with. They're really nicely anchored in our natural psychological systems, and for that reason, we can get high fluency. They've been with us a long time. They develop early in childhood. They're kind of easy. They're really good cultural forms to spread. Down on this other end, on the other side of playing chess, is probably doing science. It's hard. It takes lots of cultural investment, or scaffolding, he calls it, lots of special conditions. Developing new mathematics to handle this stuff, labs, equipment, literacy, lots of cultural support, and even still, most of us get nowhere near fluency, automaticity, and ease. It remains difficult and challenging. Have to concentrate a lot. Maybe somewhere over in here is literacy. We kind of think that many of us, once you've learned how to read, you can't help but read things on this, right? There are words up here, you can't help but read them. That's fluency, automaticity, and ease, but don't forget, you had to work really hard to learn how to read and write. It was drilled into you in your early school years. Hours were spent doing this. You had to be taught how to do it. And not everybody finds it that easy to acquire. We call them learning disabilities, but they're only disabilities because literacy is now the cultural environment in which we have to swim. If there wasn't literacy, those disabilities wouldn't even be noticed. They wouldn't be disabilities. Okay? So, I realize that I need to save you a little bit of time for some questions here. I've gone on a long time, but that's because I wanted to give you enough of the sort of the conceptual furniture that then we can start thinking about certain kinds of technologies tomorrow and why they spread the way they do, why they can spread broadly and deeply. So the quick suggestion from this kind of analysis is this. If a new technology has deep roots, is well grounded in our cognitive system such that it's easy to think or easy to use, that's a point in its favor in terms of spreading widely. If it also maybe can throw in some super stimuli or be just a little bit counterintuitive, that might make it give it another spark, make it a little more attractive and interesting, make it stand out. If it manages to, be aimed at our natural motivations, cross-culturally recurrent, historically recurrent human problems that maybe our evolved nature sort of encourages us to try to solve, that's going to be a stronger candidate for this broad spread, because by virtue of being human beings, we all care about those things. What's an example? A quick example of the distinction I'm talking about there. Difference between gossip and trivia. By virtue of being a human being, we all care about gossip. Okay, it's a certain type of information. What is it? It's social information about who's got the goods, who's in relation to whom doing what in the shadows. It's salacious. It gets our attention. We want to talk about it or want to not talk about it because we know we want to talk about it and we shouldn't talk about it and we shouldn't be. Whereas trivia, how many species of beetles live in the Amazon river basin? No one cares. That's just information. That's not gossip. Around the world, we care about gossip. Only, certain kinds of field biologists might care about this particular trivia, or certain kinds of architectural nerds might care about that kind of trivia. But we all care about gossip. Why? Because of our social nature. So that's getting closer to these natural kinds of drives and motivations that we have. So technologies that manage to sort of poke those right buttons the right way, I suggest, have much better likelihood of spreading broadly and deeply and becoming so ingrained into our culture that they're hard to give up, even if they turn out to be bad for us. But that's what I'm going to develop tomorrow. So I will stop there for tonight. Okay?